This is Unit 2.7, question 17 of the test prep. What is the slope of the line tangent to the graph y equals 2 ln x when x equals 8? So the first thing we want to do is to find the slope of the graph at the slope of the tangent line of the graph at a point. We first need to take the derivative of our function. So we're going to take the derivative with respect to x of 2 ln x. So using the constant multiple rule, this is the same as 2 times the derivative of ln x. And we know that the derivative is 1 over x, so we get 2 times 1 over x. And then multiplying this together, we get 2 over x. So this is our derivative. We're now going to plug in the value 8. So we get, f prime of 8 is equal to 2 over 8. And then f prime of 8 is equal to 1/4 by simplifying this. So our final answer is 1/4. This is Unit 2.7, question 19 of the test prep. If x equals 3, then the limit as h approaches 0 of ln x plus h minus ln x over h equals what? So now, while you could do the limit the normal way and then plug in 3 at the end, the main thing we're going to do is we're going to see this as the definition of derivatives. So basically, when you have the derivative of a function, let's say f of x, that is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So now if we're taking the limit, so if this is just the derivative function, we're going to work backwards and trying to find f of x and then just derive it as we know how. So we can see that minus f of x is at the very end. So we can just see what you're subtracting at the very end, which is ln x. So we're trying to find the derivative of ln x when x is equal to 3. So the derivative of ln x is 1 over x, and if we plug in 3, we get 1 over 3 as our final answer. Our next question says the limit as h approaches 0 of cosine pi over 6 plus h minus cosine pi over 6, I don't know why there's parentheses there, all over h. So now, for this question, we want to do the same thing that we did the last question, recognize this as the definition of derivatives. So this is basically the derivative of cosine of x when x is equal to pi over 6. So we know that the derivative of cosine x is negative sine x, and when plugging in negative 6, we get negative sine pi over 6. So now, to calculate sine of pi over 6, we're going to use our unit circle. So I'm just going to draw it right here. At pi over 6, our coordinates, this is pi over 6, our coordinates are root 3 over 2, comma, 1/2. And our sine value is always our y value, so the sine of pi over 6 is 1/2. So our final answer is negative 1/2. Our next question states if the f of x equals sine x, then the limit as x approaches pi of f of pi minus f of x over x minus pi equals what? So now we need to recognize another definition. If we have f prime of some c value, that is equal to the limit as x approaches c of f of c minus f of x over x minus our c value. So now what can we do with that information? Well, we can just take the derivative of our f of x, which we know is sine x. So let's take the derivative d over dx of sine x, and we know that's equal to cosine x. And now we know that we're finding f prime of c, which is pi, so we can just plug in pi into here. We get cosine pi, and to calculate cosine pi, we're going to use our unit circle once again. Pi would be over here, and our coordinates for pi is right here. Our coordinates would be negative 1, comma 0. So cosine pi equals our x value coordinate, which is negative 1, as our final answer. This is Unit 2.7, question 21. Line L is tangent to the graph y equals 2 sine x at the point k, comma 2 sine k. For 0 is less than or equal to k, or less than k, which is less than 2 pi. For what values of k does line L pass through the origin? Okay, let's start by dissecting this question. Let's start by writing down our graph, y equals 2 sine x. This is a huge question. We have line L, which is tangent to this graph, which means line L has the slope of the tangent, has a slope of the derivative of this when x is equal to k. So let's start with that information. Let's start by deriving this function 2 sine x. So dy over dx is equal to, remember we can take the 2 out of the derivative and derive sine, which is cosine x. So we know that our derivative is cosine x. If we plug in k, we get 2 cosine k. So this is our derivative when x is equal to k. Now let's start with our formula. Our formula for line L is y minus y1, or our point slope form, equals m x minus x1. Alright, we know that our slope at x equals k is 2 cosine k. So let's just write that in, 2 cosine k. And then we know that our x is at the x value, x equals k. So x minus k. And then for our y1, we're just going to plug k into our original problem, which is 2 sine k. 2 sine k. So now we got all this information. When it passes through the origin, that means y and x are both going to be 0. So we get negative 2 sine k equals 2 cosine k times negative k. Alright, so now to solve for k, we actually can't do this like just algebraically. We're actually going to have to use a calculator. So we basically graph this function and then graph this function and see where they intersect at this, in this area. So from 0 is less than k, then it's less than 2 pi. And we get a final answer by checking the x value of where they intersect. We get a final answer of 4.493, which is our final answer. This is Unit 2.7, question 22 from the test prep. F of x equals x plus a cosine k, where a, that's not supposed to be k, this is supposed to be an x. F of x equals a cosine x, where a is a positive constant, and 0 is less than or equal to x, which is less than or equal to 2 pi. Find the x coordinates of all points 0 is less than or equal to x, which is less than or equal to 2 pi, where the line y equals x plus a is tangent to the graph f of x. Okay, let's dissect this question. So now we can, so this is the tangent line. This has a slope of 1. Slope of 1. That means that the derivative at this x value, or wherever this tangent line is, we know that it'll have, hold on, let me rephrase that. So what this means is that at the x coordinate that this is the tangent line of, we know that the derivative of this function at x equals that value will be equal to 1. So from that information, let's find where the derivative of this function is equal to 1. So let's start by taking the derivative of the function d over dx of x plus a cosine x. So the derivative of x is 1. Remember, we can move the a out of the derivative, and the derivative of cosine x is negative sine x. So we get 1 minus a sine x. And we're going to set this equal to 1, because that's what we're trying to find the derivative. I'm going to subtract 1 from both sides, so I get negative a sine x equals 0. We get sine of x equals 0. So now solving for x on the unit circle, there are 2 places where sine of x equals 0. And that is at 0 and pi. This is where our y value is 0, so our sine x equals 0. So we get x equals 0, we get x equals pi. And remember, we need to find one more point, which is 2 pi, by adding 2 pi to 0. Because remember, you can go, this is also the location 2 pi. So these are all our x values where our function has this as the tangent line. Now this is not actually our final answer, because the tangent line and the function need to have the same y values when you plug in our x values. So let's test all of them. Our slope of our tangent line is x plus a, and then our actual function is x plus a cosine x. So now let's start by plugging in 0 into all the x's. We get a equals 0 plus cosine of 0 is 1, so we get a equals a, so 0 is the solution. Now let's plug in pi into all the x values. We get pi plus a, and then on the left side we get pi. Cosine of pi is negative 1, so we'd actually get pi minus a, which is not equal, so pi is not a solution. Finally, let's plug in 2 pi. We get 2 pi plus a equals 2 pi plus And then cosine of 2 pi is 1, so we get 2 pi plus a, which is equal, so 2 pi is the solution. So our actual solutions are x equals 0 and 2 pi as our final solutions. Alright, that's it for 2.7. Next we'll be moving on to 2.8.